Hello, welcome back to the Geography 300 WU Geographical Data Analysis video series. This is the fourth and final video on how we can describe our data and using descriptive statistics. This is, of course, a geographical data analysis course, and what we have seen thus far is useful for describing the attributes of our data set. Of course, we may be interested in the locations. And so this video looks at spatial description and how we do that, and especially within the context of a series of points. So I will put points up here on the board. So here we have our points. The first attempt at a summary that we might be working with is kind of like the mean or the median. We can actually do something similar to both. We can take what is the middle and find the centroid. And the centroid is simply the mean of the x values and the mean of the y values. The way I drew this, the median center would be pretty much the same. So and if I took the median of the x values instead of the mean, and the median of the y values instead of the mean, I'll get the median center. In many cases, they are close to each other, but if the data are such that they're quite, in a sense, spatially skewed, pushed off towards one part of the study area or another, they can, in fact, end up being fairly different. That gives us essentially our center. I can adapt this to say not just the center, but give each of the points kind of a weight. It becomes a bit more of a challenge to convey. But if I can think of my study area and the points as basically a flat surface, the centroid would be where does it balance? If I then say, okay, some points are kind of worth more than others. This shows up in say a population center. I can say take every city in the US, put a dot there, and find the centroid. But recognizing some cities have a greater population than others, I may want to weight that. And so I kind of push down here on New York, and I push down on Los Angeles. Morgantown is present, but it's not pushing down nearly as much. Once I put all those pressures on, once I add all of those weights, the center is going to shift. That shift is the effect of the weighted centroid or weighted mean center. Once I have the center described, or the central tendency as it were, through the centroid, the median center, or the weighted mean center, I can then look at measures of dispersion. then gives us something equivalent to the standard deviation, is the standard circle. It goes around the centroid. And it follows the ideas of the standard deviation. If I specify I want to have a standard circle, of 2 standard deviations, then just as with our attribute data, 95% of the data is within 2 standard deviations of the mean. It is a circle centered on the centroid, following the mean, and its radius is such that, I didn't draw it big enough for this, 95% of the points are within that circle. You need to add a few to make that 95% true. So that is the standard circle. Recognizing, and as here, we may not have truly circular data. The points don't form a nice circle. We may instead represent the direction of the data sum with what's called a standard ellipse. It's going to, again, follow the same idea that 95% of the points will be inside. But it is set up to be the smallest possible ellipse where that is true. So we can see, because by taking in some of these points over here, leaving out some of the points at the top and bottom of the standard circle, we can get a smaller ellipse that would have the same number of points. That is the idea behind the standard ellipse. Those become 2 different ways, the standard circle, the standard ellipse, following on from the centroid and the mean center, of identifying ways or representing ways of summarizing, describing the spatial distribution of our data, not just the attribute distribution, or the distribution of a single attribute. Excuse me. So again, as always, if there are questions, please email, please speak up in class, and I will see you at the next video.